Let's see one more problem on gyroscope. A four-wheeled trolley car of mass 2500 kg runs on rails which are 1.5 meter apart and travels around a curve of 30 meter radius at 24 km per hour. The rails are at the same level and each wheel of the trolley is 0.75 meter in diameter, and each of the two axles is driven by a motor running in a direction opposite to that of the wheels at a speed of 5 times the speed of rotation of the wheels, and the moment of inertia of each axle with gear and wheels is 18 kg meter square, and each motor with the shaft and gear pinion has a moment of inertia of 12 kg meter square. So the center of gravity of the car is 0.9 meter above the rail level, and you have to determine the vertical force exerted by each wheel on the rails, taking into consideration the centrifugal and the gyroscopic efforts, and you have to state the centrifugal and the gyroscopic efforts on the trolley. So this is the question with the given data. Let us take data which is mass is given. So m is 2500 kg, so the x is nothing but 1.5 meters, and then radius is given as 30 meters, so r is equal to 30, and then velocity is given, that is 24 kilometer per hour. So speed, so we can convert it into meter per second, so it will become 6.67 meter per second, and then diameter is given here 0.75 meters, so dw is 0.75 meter, and then radius will be 0.375 meter. So g will be equal to omega e by omega w, that will be nothing but 5. So this is given 5 times, so we take it as 5. Then iw is given here 18 kg meter square, and then ie is given as 12 kg meter square, and the center of gravity of the car is a 0.9 meter above the rail level, so it is height is nothing but 0.9 meter. So you know the weight of the trolley, w is equal to m into g. So from there, that will be distributed over all the four wheels, which will be acting downwards. So the reaction force between the wheels and the road surface of the same magnitude will act upwards. So the road reaction on each wheel will be divided by each wheel. So that will be total on each wheel will be total load divided by 4. So it will be mg by 4. So 2500 is total weight. If multiplied by 9.81 divided by 4, so on each wheel you will be getting 6131.25 newtons. And you know that angular velocity omega w will be nothing but v by r w. So you get from here velocity is known to you, and r w is also known to you, so you get value as 17.8 radians per second. Then angle of precision omega p can be calculated by v by r, so you get 6.67 divided by 30, we get as 0.22 radians per second. And gyroscopic couple on one pair of wheels and the axle, you can get it for Cw as 2 into I omega p here by this formula. So for all wheels we will be taking, so you get 2 into 18 into 7.8 into 0.22, you get 141 Newton meter. And gyroscopic couple for the rotating parts of the motor and gears, so that will be CE. So this was with respect to wheels. This is for the engine part, gyroscopic couple 2e omega p, so it will becomes, the value will be substituting 2 into 12 into 5 into 1, 17.8 into 0.22, so you get 470 Newton meters. So the net gyroscopic couple C will be equal to Cw minus Ce, so you get 140 and 470, so the difference is minus 329 Newton meters. So negative sign is actually used to is due to the opposite direction of the motor. Okay, so but mainly the couple will be nothing but 329 only, so only the direction for the opposite direction of the motor, so this is why negative sign. Then due to this, the net gyroscopic couple, the vertical reaction on the rails will be produced, since C is greater than Cw, so therefore the reaction will be vertically downwards on outer wheels and the vertically upwards in the inner wheels. So let us take the magnitude on that is of this reaction at each and outer and inner wheel will be p by 2 newtons. So therefore p by 2 is equal to C by 2x, that is equal to 329 divided by 2 into 1.5, so you get 109.7 newtons. and you know that centrifugal force is nothing but Fc is equal to mv square by r. So taking mass, velocity and radius into account, you get 3707 Newton, and overturning couple will be equal to Fc into h, so that will be equal to 3707 into zero point 0.9, so you get 3336.3 Newton meter. And this overturning couple is balanced by the vertical reactions, which are vertically upwards on the outer wheels and the vertically downwards on the inner wheels. So let the magnitude of this reaction at the each out of the outer and the inner wheels, that will be q by 2 newtons. So q by 2 will be given c naught by 2x. So here you will be getting 112.1 newtons, and the vertical force exerted on each outer wheel will be P naught, will be nothing but W by 4 minus P by 2 plus Q by 2. So you get here for each wheel, outer wheel will be 7142.65 Newton, and the vertical force for this on the each inner wheel, that will be inner part, so Pi, so P outer was 7142. In the same manner you get here plus W by 4 plus P by 2 minus Q by 2, so you get 5128.85 Newton. So for the outer wheel you get 7142, and for the inner wheel you get 5128.85. So these are the answers.